Hello, my name is Dan Castrogano, and I am an educator and a community organizer. I've been teaching about climate change for 6 years now and have recently given a couple of talks on basic climate science and the current state of the climate crisis, and wanted to make a recording to share exactly where we stand halfway through 2023. I'm recording this on Sunday, June 25th, 2023, and really just want to wake people up, and for people to understand the truth of where we actually stand and how urgent the climate crisis is, such that we can act. I've given this talk a lot of times from middle school students to grad school students, family, friends, activists. A lot of this is very grim and very bleak, and that is the nature of it. It's still the truth. And so know that whatever you feel, your feelings are valid. Those are natural and normal responses to a worldwide crisis. And I just wanted to share that, and that I also feel all of the feelings all of the time when working on climate. And so I hope that this presentation is helpful, and I will do my best walking through this slideshow. So we'll start at the very beginning. Greenhouse gases keep the Earth warm. We've known that for a very long time, since the 1800s. We live in this Goldilocks zone next to a medium-sized star where we have liquid water and life exists. It's amazing. It's incredible. We know that greenhouse gases keep the Earth warm. There are some greenhouse gases on the right side, so we know about carbon dioxide. There are other greenhouse gases, including methane, nitrous oxide, a group of synthetic or man-made gases called fluorinated gases, and then also water vapor. All of these keep the Earth warm enough for life. And humans are putting more greenhouse gases into the atmosphere through a lot of different things, like burning fossil fuels, raising livestock to eat, cutting down forests, and lots of other things. And these different greenhouse gases heat the Earth in slightly different ways. So if we use carbon dioxide as the base unit, GWP stands for global warming potential, and the subscript 20 stands for over the course of 20 years. So if we use that as the base unit, carbon dioxide over the course of 20 years has a global warming potential of 1. And then looking at methane, we see that it heats the Earth 105 times more than the same unit of carbon dioxide. Nitrous oxide heats it 260 times more. And then this group of gases made by humans, there aren't very many of them, but they have tremendous heat trapping ability, and on average are 10,800 times more heat trapping than carbon dioxide. Water vapor, like I mentioned in the last slide, is part of the water cycle. The water cycle is out of whack and is amplified because of climate change, but it's not listed here. So there are many greenhouse gases, and the way we measure all of the greenhouse gases is a unit called CO2e, or carbon dioxide equivalent, which measures the impact of all of these gases in terms of the amount of carbon dioxide that would create the same amount of warming. So you kind of take all of them, you say, if they were all CO2, this is what would happen. And each of these gases, their effect on the climate depends on a few things: how much there is in the atmosphere, how long they stay in the atmosphere, and how well they trap heat. So the graph on the left side shows that we've put the most amount of carbon dioxide into the atmosphere. About 80% of emissions are from carbon dioxide, and you can see the remainder is from the other gases, including the fluorinated gases, which are called that because they all have F, fluorine, in them. And on the right, here's a screenshot from the EPA basically showing where all of these greenhouse gases come from. Carbon dioxide comes from burning fossil fuels, cutting down forests, lots of other things. Methane comes from a lot of places, basically from the fossil fuel industry, and from livestock, and from decaying organic matter in landfills, and lots of other things. Nitrous oxide comes from a lot of different places, particularly from applying too much nitrogen fertilizer on our agricultural lands, and then Nitrous oxide is a byproduct of that. And then the fluorinated gases come from lots of different household, commercial, and industrial applications and processes. So we'll pivot a little bit, a few slides on climate justice. And so where have all of these come from? This chart, this graph runs through 2017. This is before Brexit. So we have the EU 28 instead of EU 27. But it basically shows that the global north is historically most responsible for the climate crisis. So the States, Canada, and the European Union and European countries. So it's important to know that historically, where has all of this come from? And historically, it is mostly from the global north and from the privileged places on Earth. There are a lot of different ways you can look at who's responsible for climate change. This is from a 2020 Oxfam report. So instead of putting it to countries, you can also put it to individuals or assign emissions to individuals. This shows that the richest 1% are responsible for 15% of all emissions. The richest 10% are responsible for more than half of all emissions, while the poorest 50% are responsible for only 7% of all emissions. So the climate crisis is all about wealth inequality as well. This is another way to look at, which is per capita emissions by country. So this is an average, right? There are very wealthy people in the United States who have who create pollution on a much bigger scale than 15 tons. And there are a lot of people who have fewer, but on average, the United States is about 15 tons per person. And I picked some countries to show the difference in per capita emissions. And this data is from Our World and Data. So it's important to think about there are a lot of different ways you can think about where emissions have come from historically and currently. So let's talk about carbon dioxide in the atmosphere. And so this is really probably the most important number when we talk about climate change is atmospheric concentration of carbon dioxide. And so this graph goes over 800,000 years on the x-axis. And the y-axis is in carbon dioxide in parts per million. These are proxy measurements because humans like us have been around for about 200,000 years. And we didn't start actually measuring this until 1958. So this is through studying ice cores and other proxy measurements where we can look at the gas bubbles that are trapped. So as you can see, it kind of fluctuated between about 180 and 280 parts per million. These are the ice ages that happened over and over again due to these natural cycles called Milankovitch cycles. So the circularity or how elliptical the orbit of the Earth is, the tilt of the Earth, and then the angular momentum of the Earth. So all these things kind of play out differently, and all of the other natural cycles that happen on Earth when humans weren't impacting it at this huge scale. And then human civilization about 5,000 years ago or 6,000 years ago with the ancient Mesopotamia and Egypt and China and India and all over the world, human civilization and agriculture was built on the fact that carbon dioxide in the atmosphere was about 275 parts per million. And you can see at the very end, since we learned how to burn fossil fuels, it has skyrocketed. And so now we just peaked at 424 parts per million. So our civilization is built on the fact of 275 parts per million, and now we're up above 400. We're at 424 as of the average of May 2023. So a couple of more graphs here to ground us in some data. This is called the Keeling curve in the bottom left, and it's named for Charles David Keeling, who is a scientist who started measuring atmospheric CO2 at Mauna Loa in Hawaii in 1958. So these aren't proxy measurements, these are actual measurements. In the top left, you can see that the average for May 2023 was 424 parts per million, which compared to the previous year's 3.01 parts per million more. So that was a big jump. It's usually about 2 to 3 parts per million more per year because of what humans are doing. And so the graph in the bottom left shows that exponential growth of atmospheric carbon dioxide over time. And so it has clearly gone up from when measurements started happening in 1958. In the bottom right, we have, and you can see on both graphs, this sawtooth curve. And you can see, and the reason for that is the northern hemisphere has more land, and there are more forests and plants and crops and flowers and everything. So in the northern hemisphere, summer, everything grows, and it actually, like a deep breath, draws down carbon. So it's like the whole earth is breathing. And so during the summer that happens. And then during the winter, when all that stuff dies, the deciduous plants die, all of that is released back into the atmosphere again on this annual cycle. So it goes down and up every year. So now it's June 25th, 2023. We're basically at the peak. It basically peaks in May, and then it goes back down and about, it goes back down, and then the valley is in about September. And then next May 2024, it's going to peak again. And it'll peak at maybe 426 or 427 parts per million, because that's about how much it grows every single year. The last time atmospheric CO2 was at 424, which is what we have right now, was during the Middle Pliocene, which was 3 to 4 million years ago. And when CO2 was like that, temperatures were 2 to 3 degrees Celsius hotter, and sea level was 90 feet higher. This is a tweet from Archibong Akpan, who's a climate scientist who's reviewed the 4th and 6th assessment reports for the IPCC, basically highlighting this article. And all of these things are in a slideshow that I will share when I put this on YouTube. So you can click through all of my sources and explore all of this stuff further. So clearly, greenhouse gases trap heat. So this is the global average surface temperature. You can clearly see that it is getting hotter on Earth. And there are a lot of ways to look at it. This is a visualization from Professor Elliot Jacobson showing the anomaly. And an anomaly is a difference from the norm or from the baseline. And so you can clearly see that it is getting hotter over time. This one is cool because each stripe is a day, going back to January 1st, 1979. And you can also clearly see that 2016 was the hottest year so far. And that was the last year that we had El Nino. And El Nino is a global weather pattern that makes the Earth slightly hotter. It is the opposite of La Nina, which makes the Earth slightly cooler. And so 2016 was the last time we had El Nino. And El Nino was just announced again. We've just entered into an El Nino as of June 8th, 2023. So that heating effect is about to happen starting in 2023. We're coming out of a 3-year triple dip La Nina. So 2020, 2021, and 2022, as you can see, were La Nina. So there was a slight cooling effect because of La Nina. And now we've entered into El Nino as of June 2023, and that will heat up the planet again. The oceans absorb about 90% of the excess heat that we have put into the atmosphere. And so you can, again, clearly see there's a lot more energy in the oceans because of humans. So a good question that I want people to understand is how much hotter is it before the Industrial Revolution, before humans started burning fossil fuels? And we can use 1850 as basically the year. And the answer is about 1.3 degrees Celsius. So this is from the homepage of Berkeley Earth. This is a tweet from a little over a year ago from climate scientist and activist Peter Kalmus. We're at about 1.3 degrees Celsius of heating compared to before humans started burning fossil fuels. And where are we shooting? So you might be familiar with the Paris Agreement, which was signed in 2015. And this is Article 2 from the actual document. So it says we want to hold the temperature to well below 2 degrees Celsius and to pursue efforts to limit the temperature increase to 1.5 degrees Celsius. This document is now 8 years old. And so this has guided a lot of thinking. And we want to, every fraction of a degree of heating impacts the planet, and we want to avoid. But in particular, 1.5 is a threshold that scientists of the world identified 8 years ago as a threshold we should not cross. So where do we stand today? So this is the global 2-meter daily temperature, and that's the whole Earth at 2 meters, which is about 6 feet. And we've crossed that 1.5 degrees Celsius barrier a couple of times, as you can see. So in June and then earlier in the year as well, where it gets over the red line. And that doesn't mean that we've broken the Paris Agreement. It just means for some days of time, we've crossed 1.5, but it's not, a month-long average or a year-long average, or in the case of climate, which is 30 years or more, we've not crossed it, but we have crossed it, for several days at a time, more than once already. So another good basic climate literacy thing to know is how many tons of greenhouse gases do we put into the atmosphere every year? And so this is in carbon dioxide equivalents, or CO2e, like I mentioned before. And the answer is a little bit over 50 billion tons, or 50 gigatons. This is from Our World in Data. You can clearly see after the Industrial Revolution, it's skyrocketed since then. So it's about 50 billion tons, or 50 gigatons. So a natural follow-up question is like, okay, so what's our carbon budget? And it's important that even if your data is a few years old, that it is out of date. That it's important to tell the truth and to look at what is happening right now. And so that's why I'm making this video. This just came out on the 8th of June. And the third paragraph that I took a screenshot of below shows that there are about 250 gigatons left for 1.5 degrees Celsius. And that's 5 years worth at this current rate. So 5 by 50 makes 250. So that's 2028, and when we'd cross 1.5 degrees Celsius. We'll come to a few items that basically prompted this talk, this kind of over and over again, these scientific reports and these news of climate catastrophes happening. So the first was climate fires in Quebec in Canada, which brought the apocalyptic looking smoke to New York City and lots of places on the East Coast. So clearly you can see that there have been the most amount of wildfires in Canada in 2023. And then this chart's also out of date too, right? So it's really hard to capture all of the news in one snapshot. So all of this stuff's from June 2023, and I'm doing my best to keep it up to date. There's also been incredible heat in Mexico and Texas. This is from Jeff Brardelli, who's a meteorologist and a climate communicator, right? He's saying that, the normal historical climate, it's basically statistically impossible. So incredible heat in Mexico and Texas, with the heat index at 120 degrees Fahrenheit plus. The global oceans are extremely hot. There is now a category 4 and 5 marine heat wave in the North Sea and off the coast of Ireland. Extremely, extremely hot temperatures in the oceans. Ben Knoll is also a meteorologist, and in this tweet, he's basically showing that the temperatures in the oceans are kind of what they should be in September, when the oceans are a lot hotter when they are in June. And the box that he's got there is called the main development region. And that's where hurricanes form and then move west and then hit the Caribbean and Central America and the United States. And basically, so, this is showing that it's going to, there's more energy in the ocean, which means that it will be a very active hurricane season. This news just came out last month. We are currently experiencing the 6th mass extinction. There have been 5 extinctions beforehand. The 5th one was the dinosaurs. That was 65 million years ago. This one, Anthropocene, means human or human caused, is because of human beings. And so more research came out that, basically it's worse. It's worse than we thought. Here's another visualization of sea surface temperatures going with the temperatures that I showed previously. You can again see that 2016 was the hottest year on record with those very dark lines. This shows sea surface temperatures from 60 degrees south to 60 degrees north. So that excludes the Antarctic Circle and the Arctic Circle. So it's the middle part of the Earth. And then you can see just the incredible heat in the oceans as 2023, as we reach the middle part of 2023. And then this one is, shocking. It's alarming, to say the least. This was on June 21st. This is 4 days ago. Bill McKibben, who's an author and climate activist, and many other communicators and scientists are sounding the alarm, saying this is the North Atlantic sea surface temperature anomaly, the difference from the norm. And it is, when you say off the charts, like there have been people who have had to increase the height of the chart because there's so much heat in the North Atlantic right now. And so this graph alone should be headlines everywhere. It's unfortunately not. It was the hottest ever start to June. It's a global temperature spike. So that's important as well. This also just came out, that the Arctic will be ice-free in the summer no matter what we do. So under any of the scenarios for emissions, it is inevitable. So it's basically crossed this point, and then this part that I highlighted on the left side, under all scenarios considered, we project an ice-free Arctic in September. So there will be no ice at all in the Arctic. On the other side of the Earth, at the South Pole, Antarctic sea ice is also similarly catastrophically low. So on the left is in the extent in million square kilometers compared to previous years. And on the right, those are anomalies, which is the difference from the baseline. So these graphs alone on ice should wake people up. Here's another way of looking at Antarctic sea ice. This is from a couple days ago. Just again, catastrophically low. This is from Professor Elliot Jacobson. This just came out a couple days ago, that Himalayan glaciers could lose 80% of their ice by 2100. This provides water and water to irrigate food for the subcontinent of India and much of South Asia. So again, it's just bad news after bad news after bad news. And this is why it's important to see this. It is important to wake up and to tell the truth and to not look away, that we have to act with urgency. So like I said before, El Nino was announced on the 8th of June. And so this is, it impacts global climate and global weather. It basically, the eastern part of the Pacific Ocean, as you can see, this map is now from June 8th. So there is more heat in the ocean than the map on the right, but the eastern part of the Pacific Ocean heats up. And then once it reaches a certain threshold, El Nino is announced, it becomes El Nino. And so that is what we are now currently experiencing in June 2023. So what is the UN doing? And like, can we hit 1.5? That's the next question. This is called the Emissions Gap Report from the United Nations, and it comes out every October. And this showed in blue on the left side that there is, quote, no credible pathway to 1.5 degrees Celsius. It also shows, and this is very optimistic, I think, that we're going to head for 2.8 degrees Celsius, which is catastrophic. And that takes into consideration a lot of unproven technologies of basically carbon capture. And all of these models from the United Nations are saying we're going to take this chunk out, in the 2070s and 2080s and 2090s. So anyway, the report from the United Nations right now says we're headed for 2.8. This graph from the IPCC is important, and I wanted to share specifically the blue line. And the blue line is what we have to do. Again, they said there's no credible pathway. Here's the pathway, showing essentially an immediate almost exactly straight down line to bring it to 1.5. And what I said before is all of that stuff under net zero, which is not zero. All that stuff under net zero is this huge amount of carbon dioxide that is in these best case scenarios by technology that isn't scaled yet, drawing all of this out of the atmosphere. So anyway, that's the slope of what we would have to do. So this is called En-ROADS. It's from Climate Interactive and MIT. It was just updated on June 1st. And it shows under current policies, we're headed for 3.3 degrees Celsius or 5.9 degrees Fahrenheit of heating. So it kind of depends on how optimistic you are and what you look at as far as technological drawdown in the end of this century, at the end of this century. So this one says 3.3 degrees Celsius. This is a great tool if you'd like to play with different stuff and see where we're headed. This is climate scientist Kevin Anderson, who just spoke a couple of weeks ago and says we're headed toward 3 to 4 degrees Celsius of warming across the century. And for Americans, that's 5.4 to 7.2 degrees Fahrenheit. So where we're headed kind of depends on how optimistic you are. And Kevin is a truth teller and doesn't think we should bank on these technologies that we don't have right now to pull out enormous amounts of carbon from the atmosphere. So I think this will start playing. Apologies for that. So this is a really important graph to see what the countries of the world have accomplished. And we've known about global heating since the end of the 1800s. We've known the greenhouse effect. And the first IPCC report was in 1990. So you can see all of these protocols and accords and meetings and summits are on the top. The warming stripes are on the bottom, right? So it's getting hotter. And then on the left is atmospheric carbon dioxide, right? So it's climbing. And you can very clearly see that we have failed, right? What we've done, countries of the world, we have to come back down, right? And so we can see that what has happened from the United Nations, all of these words, you can't trick physics, right? Carbon dioxide traps heat, and we're pumping more and more of it into the atmosphere every year. So for all of the fancy words or greenwashing, it's getting hotter because that's how physics works. Amid all of this, on the right side, in 2022, the big 5 fossil fuel companies had record profits in 2022. So that's Exxon, Chevron, Shell, BP, and Total Energies. So the fossil fuel industry is alive and well, and we have to end the fossil fuel industry. We have to stop burning fossil fuels. On the left, Shell, one of the big 5, recently announced it's basically not it's not doing what it said it was going to do, and instead is going to invest $40 billion in oil and gas over the next 12 years. So the fossil fuel industry is alive and well, making record profits and walking back their talk. COP28 is in the United Arab Emirates this year. COP stands for Conference of Parties. It's the 28th annual summit of countries of the world to talk about what they're going to do about climate change, This is the person who's in charge. His name is Dr. Sultan Ahmed Al-Jaber. He is a fossil fuel oligarch. He is the chief executive of the Abu Dhabi National Oil Company, and he is the president of this conference. And it just came out that the oil company, ADNOC, is able to read all of the emails from the United Nations. So I guess I just want to be clear that we're not going to be saved by the fossil fuel companies. We're not going to be saved by fossil fuel oligarchs and by fossil fuel lobbyists who have taken over the United Nations conferences. It's just going to be regular people fighting. It's going to be regular people rising up and taking action where they live in order to preserve everything that we can preserve. So here's a social emotional check-in, which we do when we teach. Any emotions that you're feeling at this point in the video are normal. I waver through periods of sadness and intense anger, anxiety. When I think about all of this stuff, all of this is true, and it's important to know, and it's important to act. And the more privilege you have, the more wealth you have, the more economic and social power and political power you have, the more it is your responsibility to act. So we'll take a deep breath, and we'll pause here. And then we'll move forward. So basically, what will the future look like? Again, Peter Kalmus, climate scientist, has a Google Doc that's linked. And he's got a couple of scenarios, like what will it look like under a rise scenario, and people fight and we end the fossil fuel industry immediately or as fast as possible, and then collapse. And he's cited everything. I encourage you to look through it. This is from one of his presentations showing that climate breakdown and extinction is effectively permanent. Global heating, sea level rise, biodiversity loss, and then all these tipping points that I'm going to talk about as well. There's a great platform called Probable Futures. It's at probablefutures.org. You can go through the different scenarios of 1, 5, 2, 2, 5, and 3, and then see how that changes things like heat and precipitation wherever you live. And so that's another way of looking at what the world will look like in the future. This is important to look at too, and I like just seeing the human figures on the bottom. But these are different scenarios, basically depending on when you were born, with those stripes on those people. The different, the darker it is, those are different scenarios. I'm a dad. I have a young son, and that's one of the main reasons that I have devoted much of my life to this work. That it depends, depending on what we do, the world is going to be, varying levels of climate chaos. So let's come to the topic of tipping points. And so a tipping point is basically something that it's like a glass of water that has water in it, and then you can tilt it on the table for a while, and then at a certain point it falls down, and then all the water spills out, and it's impossible to get the water back to where it is. So it tips over, and it can't be restabilized to its previous state. So on the left, there are all these macro systems on Earth. There are many we've talked about: Arctic, Antarctic, some we haven't, reefs, the Amazon, the circulation of the oceans, the Himalayan glaciers. This paper that's featured on the right shows that basically we don't want all of these things to tip over. And in many cases, they make global heating significantly worse. We have to stabilize what we've got and try to not experience what they call hot house Earth, where all these things tip over and over again. And so we have to stabilize what we've got. So let's look at some of these. So one is the Greenland ice sheet, which in 2020, it was found that it reached its tipping point. This will contribute significantly to sea level rise. This will take a long time, a couple of centuries. But the image on the left shows what's called the albedo effect. And albedo is reflectivity. So the lighter something is, the more energy bounces off, right? And the darker something is, the more energy is absorbed. This is like wearing a white t-shirt or a black t-shirt on a sunny day. And so as ice melts, it's actually creating more heating because there's less white surface and more darker ocean that is absorbing energy. So that is happening with ice all over the world and on Greenland, in Greenland. This is also happening with permafrost, which is permanently frozen soil. And in this permanently frozen soil in the northern hemisphere, there's methane, which is a greenhouse gas. And as it melts, methane heats up the earth, which melts more permafrost, which releases more methane, right? And so it's this cycle. And so there are a lot of these cycles on Earth where the hotter it gets, the worse it gets, and it creates more heating. And that's called a positive feedback loop. I think when I click this will play. I encourage you to watch that video, but we will not watch it right now. The Amazon rainforest is in dire straits. The video on the right, which I won't play, There's a person, climate scientist, saying that if we cross over, if 25% of the Amazon rainforest is cut down, it will pass its tipping point and it will turn into a savanna. The Amazon rainforest controls its own weather through transpiration, which is water coming out of plants. And so it creates its own weather. And if it's fragmented and too much of it is cut down, it will tip over and it will turn into a savanna. Going to the bottom of the Earth, Antarctica. Again, at tipping point, there's a lot of worry about this thing called the Thwaites Glacier. And there was research this month that irreversible changes will happen if we pass 2 degrees Celsius. And again, you can explore all this stuff on your own. So again, coming back to all these macro systems, we don't want them to tip over. We have to stabilize what we can. And what we do in the next couple of years, the next few years, is critical. And I know it will be true until all of us are gone, that now is the best time to act. Acting now is more important than 5 years from now. Acting now is more important than 10 years from now. And then as of 3 days ago, there was new research that said ecological tipping points could occur a lot faster than expected. So again, another emotional check-in. This stuff is really hard to hear. It is the truth. It's important to not look away. And it's important to understand what's actually happening on the planet. So we're going to look at a few more impacts. How is it impacting wildlife? How is it impacting the oceans? And then we'll look at how is it impacting humans, and then we'll be finished. So a few things here in the bottom left. The UN Convention on Biological Diversity failed. The targets that it set, it met 0 of 20 targets as of 2020. Biodiversity is declining rapidly. We are experiencing the 6th mass extinction. In the bottom right, about a year and a half, almost 2 years ago, more species were declared extinct. This is from the US Fish and Wildlife Service. In the top, and this one hits home for me every single time, it's not only extinction, but it's just fewer animals on Earth. So there were more than 20,000 populations of animals that were tracked for 50 years. And on average, their populations dropped by 68%. So depending on how old you are, if you have that anecdotal, like there used to be more insects, there used to be, more birds. I remember this, You're right. That is true. Almost 70% of animals are not here anymore out of those populations that were tracked. A bit on oceans. There's a lot going on here, but the oceans are acidifying because carbon dioxide in the atmosphere is dissolving into the oceans, and our oceans are about 30% more acidic than they used to be, which is catastrophic for a lot of reasons. There's sea level rise, overfishing algae, and then bleaching of our coral reefs, which I'll talk about more. But at the top, 90% of the heat has been going into the oceans, and we see that in the ocean temperatures right now, and as they're spiking, especially in the North Atlantic, and about a quarter of all carbon dioxide has been absorbed by our oceans. This is going to autoplay again, sorry. So David Obura says here that if we don't achieve 1.5 degrees Celsius, which again, the UN said like in October 2022, that there is no credible pathway, 99% of coral reefs will be gone. And that's in 5 years. 25% of all marine life lives for all or part of their life or relies on coral reefs. This is right now. So coral reefs are very sensitive to heat change. And I'll leave that at that. Several more impacts. As a teacher, this is important. Really struggling when you teach kids about this stuff, and you do it appropriately and age appropriately, depending on how old they are. But this group of young people, 84% were at least moderately worried. This was people aged 16 to 25, over 10 countries. And so really, really tough to grow up in an age of climate crisis. And this is impacting young people and children all around. the climate crisis is impacting public health and disease. So allergies are getting worse because of longer growing seasons. And what's more devastating is the spread of tropical diseases to places where they have not been. Things like Zika and things like malaria, where people aren't used to it, where doctors are not trained or not used to seeing it or diagnosing it. So there's this whole ecosystem of public health impacts and the spread of disease from climate change too. And this last set of slides is basically the human suffering and death. This is in the Horn of Africa and Somalia and Ethiopia and Eritrea, basically saying, this drought that kills people would not have happened without climate change. This just came out too. It just catastrophic heat and humidity. And so it's important to know about what's called the wet bulb temperature. And the wet bulb temperature is not just heat, but it's heat and humidity combined. And there's a certain threshold where humans die, right? Just like any other organism will die because there's too much heat, because we can't perspire. We can't sweat enough to regulate our temperature. And so this shows that this huge swath of land, North Africa, Middle East, South and Southeast Asia, basically will become uninhabitable. And here's this little spot in the graph, right? But India and Nigeria, just hundreds and hundreds of billions of people will be in places where there will be moments of time where it will be uninhabitable. And you can see this list of countries is essentially not responsible at all for the climate crisis. The global South, and you can see the impact here. Which brings us to a specific case which happened, it's not one day ago, this was a screenshot, but in June 2023, where I'm personally very concerned about geopolitics and conflict and war and the shutting down of borders. When people from the hotter parts of the earth have to move to the cooler parts of the earth. So about 750 people died. The headline says 78 dead, but this was when I took the screenshot, and there are about 850 people on the boat and about 750 people died. People who left from Libya, so Egyptian and North African and Libyan and North African migrants who are trying to escape and seek a better life. And essentially, no rescue effort for 750 human beings who died. This was from 7 days ago. Intense heat wave in India, killing almost 100 people. Again, the intense heat and humidity kills more people than any other climate disaster. So way more than wildfires, way more than hurricanes, right? It's the heat waves that kill people, and it kills the most vulnerable people, the sick and the elderly first. So we are seeing the real impacts of human death and suffering today and every single day. Again, I wanted to share Kevin Anderson. This is, I encourage you to watch this video. He tells the truth, and he cuts through all the greenwashing and everything, and just please watch this video. He's a good communicator. That'll autoplay, and we'll jump to the next one. And this is the final slide. And so if you've made it to this far in the video, thank you for listening. This is really hard to hear. It's really hard to do. This is the third time I've walked through this slideshow in a couple of weeks, and it's really emotionally draining to do this. But it's really important to know the truth and to wake people up, because you don't see this stuff in the mainstream media. And that's why I've dedicated so many hours, even just in the last couple of weeks, of putting this together and speaking and recording a video. The Earth is there where the arrow is. That is the Earth. This photograph was taken in 2013 from the Cassini spacecraft, right next to Saturn. All of us live there. It's the one blue marble of life in the black expanse of the cosmos, and all of us are here. And we have to act. I don't know what I would say about, my opinion on what we should do, right? There are a lot of things that we should do, but I just want to explain the urgency and the need to disrupt the status quo because of what is happening right now. And I just want people, I want as many people as possible to understand the scale and the severity of the climate and ecological crisis. And so this is a snapshot. I'm making this on June 25th, 2023. I hope this helped. Please share this with anybody you think would like to see it. I encourage you to act with passion and with bravery, and to take risks, and to disrupt the status quo, so that we can protect all that we love and all that we can, and save all that we can. So thank you for watching.